Hello, hello. Let me know if you can hear me.
I don't know if you can hear me or not.
I can hear you just fine. I guess with that figured out, we'll go ahead and get started here. So before we start the interview proper, I'll give a little bit of a preface as to what we'll be doing today.
Okay.
Yeah, so this is going to be about a 50-minute or so coding interview. As the topic you signed up for, we've focused on recursions. As you might expect, there will likely be other ways to solve the question, but if you want to do it using a recursive approach, that would be probably for the best. And as far as the time itself goes, we'll stop right about 10 minutes before the end of the time, just so I can give you some initial feedback and also so you can ask me any questions you might have.
Okay.
Yeah, beyond that, we'll be using the CodeBump link that was attached to the invite in up level. So if you wanted to open that up and jump in on there, that would be a good start.
Okay.
Cool. So in a couple seconds here, I'll go ahead and paste in the prompt for you. Feel free to ask if you have any questions, if you need any clarification, and as much as possible, try to just talk through your solution, both so you can hopefully help yourself through it, and also so I can give you better feedback and know more where you're coming from.
Okay.
Yeah, and feel free to let me know if you've already seen this question, and I'm happy to provide another one. I've got plenty built up, so no worries there.
All right.
But yeah, I think with all that said, we're about ready to get started here. So I'll just go ahead and paste in the prompt. And I'll put it right here at line 7, I suppose. Awesome. Feel free to take a look and best of luck.
Okay, great. Given an integer array of nums, you are initially positioned in the array's first index, and each element in the array represents your maximum jump length at that position. Return true if you can reach the last index, or false otherwise. Okay. Okay, so just to make sure I understand, oh yeah, let's see, explanation. You can jump one step from index 0 to 1, then 3 steps to the last index. Okay. All right, so index 0, you're initially positioned at the array's first index, which is index 0, and then each element in the array represents your maximum jump. So you can jump less than, so for the first one, I can either jump 1 or 2, I'm assuming.
Yeah, you got it.
It's your maximum. Okay. And then, so with this explanation, they chose 1 instead of 2, which would put them at the second index, and then which would allow them to jump 3 to get to the end, which is 1, 2, and then 3. Okay. And then this thing. And so you're just returning true if you can reach the last index, or false otherwise. Okay, I think I understand the question. So let's see. So since we're designing this recursively, I'll be passing an index, I think, into the recursive function and starting at 1. And then at the 0 index, which is the first one, and then I'll have to determine if that can reach the end, and if it can't, I guess the base case would be to make sure that I'm not like over, out of bounds in any way. And then I'll have to check which element would be best to go to out of the option of elements. So I might have to have a loop in there to check them all. But yeah, I guess recursively I'd want to go down to the simplest case. So I would probably try to keep going recursively towards the end, adding yeah, maybe looping through like each option and then trying out the other options to see whether they can reach the end or not, like recursively. So it would look something like a loop going through these elements for each recursive call, if that makes sense.
Yep, totally makes sense.
Okay. Is it okay to start coding it up now? Or?
Yeah, absolutely.
Okay. All right, so yes. So let's call it helper. And then I will be the index. Then I have yeah, one base case to check if I'm out of bounds, and then the other to see if I found the right number, and then return true if I found the right one. So. And then, so this jumps, is this like I guess a global variable, right? So I can just reference that.
Yeah, sure. I mean, it can be implemented in whichever way you want. I think probably the easiest is having you know, a function at the top level that will be able to call it on. But as long as you're taking jumps as an input and it's easily configurable, you don't have to worry about it.
Okay.
We will be compiling whatever code is in here. So
okay. All right. So if I were gonna do one at the top, let's see. You could just call it and then jumps, or yeah, call it main, and then just make sure that this has something. And then this would be the last index. So here I'll return true. And then here I actually need to grab the number. Yeah, so this I actually need access to this jumps. So I'll go ahead and pass this, and or I don't know. I guess there's no downside to making this nested, right? So I could make it. Here I'm gonna and 0, I guess wouldn't really be an option, I don't think. All right, so check all numbers from 1 to whatever jumps is. And so I'm gonna expect the helper function to find out in this positive base case if this number works out or not. I'm thinking so. And I plus j, and that will be the next index it will check. And then it'll return true or false. And then up here it'll return true or false. So yes, one thing I'm concerned about is if it returns false and then there's still an option afterwards for it to be true. So I got to make sure that doesn't happen. So instead of processing it this way, I think I'll have to go through all the options and just make a result variable. And actually, this is going to be return false. Okay. I'll return the result here. So it'll default to false. And then if it ever hits true, it will assign true to the result. And then it'll return this after going through all the possible numbers. But it probably could be optimized because you only need to find one. So I'd like to try to fix that, you know. So
Yeah, I
maybe,
agree.
yeah, maybe change this back to returning true or false. And then here I can check if this one returns true, then I'll return true. Otherwise, I'll keep going through those options. And okay. So let me think about this. All right, so this is checking all the numbers for this one digit, but I'm still not recursively going through all the digits, I don't think, in jumps. So I think I still need to call. Oh, no, that's probably okay. Yeah, that's okay. Sorry. Okay, so yeah, I think this will work. So should I like try to like do a test example, I guess, and write out
Sure. Yeah. Feel free
comments?
to just try running it on that example input. Obviously, that one it's somewhat trivially true.
Okay.
But you can go for that and just make sure it compiles and whatnot.
Okay. Let's.
You also may have to call the function.
Oh yeah. Sorry, I'm still not really used to using this thing.
No worries at all.
And then I pass in this, I guess.
Mm-hmm.
Okay. I guess I got, okay, hold on. And then, all right, so obviously this didn't work out, right? Okay, so can I write out stuff to the console, or is it better just to try
yeah,
to
absolutely.
without that? Okay.
Feel free to print out anything that you would find useful.
Okay, cool. So. So going through this, calling that, getting to here, calling, it's initializing this to 1. So just looking at this up here. On 1, it should be at that first one. So it's going to check. It should check 1 and 2. for J. And I'll add those to here. So here it'll be for the first one, that'll add up to the second element, which would be here. But I is 0 at that point. Yeah, let me change this. I think that's 0. So I is 0 here. So 0 plus 1 would be 1, which should leave us on the second element. And then so that's down here, and then we're on J1. So we should be on this element here where J equals 3. So it's starting, I have a lot of trouble with this. So right now I equals 1 and J will equal 1. So we're going to pass that into the helper again, which will put I at 2. And then, so yeah, I think I see the problem probably. All right, so jumps this digit, I might have to be checking to see if this value equals the length and probably not the index. I mean, in theory, I guess if this goes through all the indexes and gets to 3, which it looks like it's doing here, then when I equals 3, that should be, let's see, 1, 0, 1, 2, 3, 4, 5. That's 5. Let's see, you can jump index 0 to 1. 3 steps to the last index. So right here, we take that and then 1, 2, 3. So steps to the last index. So from this description, it seems like it should be returning true when we're on this. Okay, let's try this out. sure if this is the right way to process this. Result false.
So would you mind just walking me through the index error you're having?
Walk you through what?
Just the index error you're currently working on debugging.
The index area, is that what you said?
The index error. So any of the problems you're facing with the indexes, could you just explain, kind of from the top, what you're trying to debug?
Yeah. So I'm trying to determine why it's not equaling true. So and I'm trying to step through the code and figure out how it's processing it. So yeah, I'm starting, I guess, with passing with a 0, and then trying to calculate, like do this calculation, which would be 1, the next iteration. So, and then the value, checking the value of jumps, which is 3 here, the next call. So I was thinking, I mean, initially, and I kind of still feel like this is probably the right way to do it, is just check for I, because if this ends up getting to I, and this evaluates to true, then it seems like it would be a correct base case for the positive.
I agree with that. I think that's probably true.
Okay. Then, yeah, so it just seems like there's some issue with the base case here, possibly because when I get to let's see, when I get to I, where I equals 1, then I guess it'll go, where J should, let's see, yeah, this is kind of where I'm like trying to like figure out.
So what, intuitively, what might be happening there is that you're like, you would return true if you have that helper I plus J equal to true. But that's not, that's not the only call you're making, because you are definitely, I would check to make sure first that you are returning true when you get to that I equals 3 case. So putting a log there to make sure you're about to return true could be useful. And then also tracing the execution back up the other way, because it seems like right now you're successfully tracing the execution down the recursion tree. So it hits the last case of I equals 3, but then you're not checking what's happening afterwards.
Right. Okay. Yeah, I kind of feel like this is never getting assigned, right? Here, hold on. All right, so let me just do what you said that
Also, now that you made that change there, I am seeing line 21.
20.
Yeah, no, I see. No, that does make sense, but I agree that maybe it was never getting assigned.
Okay. Yeah, I could just do this
You
too.
can try rerunning it now.
Yeah.
We'll see if.
I think I switched it around and kind of screwed myself up a little bit at one point.
That happens.
Oh, wait.
Also, you're assigning return currently.
That's, yeah, that won't work. All right. Result undefined. Okay, so yeah, I guess it's not even getting in here though yet still.
I'm guessing what's happening is that jumps is undefined.
Okay.
Because that's the only case it would return undefined is if that return jumps returns undefined.
Oh yeah, I see. So this would be false. Oops.
Oh, maybe not.
Okay.
I guess it's possible that your helper just doesn't return anything.
Yeah,
It's kind of an odd case.
Return false here. Okay, yeah. I guess it wasn't hitting any of these somehow. Okay. So it's still not getting to the positive one, which is so yes, I gets to 3. But the length is like 1, 2, 3, 4, 5. So that would be like 4. So I still, yeah, it's not getting like as far as it should. Apparently, doesn't seem like. Let's see.
So one thing here is, what is the rationale behind calling? So you have from J1 to J less than jumps of I. So that would be for all relevant jumps. You're going to call the helper current position plus that jump.
Equal to. Yeah, there we go.
There we go.
Yeah.
Okay, cool. Makes sense.
Cool.
Here, I'll pass you at least 2 more that we can do on this version. So I'll pass you 2 that should fail now. I'll go ahead and just paste them in right under the explanation.
Okay.
So I'll have example 2 and example 3. Both of these should return false.
Okay.
Very nice. Seems good.
Okay. Cool.
Cool. While I do think that this is a working solution and one that would probably work for any test case, I think it could probably still be optimized. So would you mind walking me through just what you think the time complexity of this solution is?
I think, let's see. So we have to go through worst case every index here, and then so, and then it's kind of it's recursively going through each following index, so it would probably be a big O of n squared.
Yeah, I agree.
Okay.
And I do think there's a way to cut that down. Because as you can imagine, you're probably doing a lot of redundant work there.
Yeah.
With checking things that you know, have already been calculated or will already be calculated. So what do you think some ways that you can improve that? Feel free to obviously take as much time as you need, but
Okay. Well, yeah, it does seem like there would be like a dynamic programming result or option possibly. But we're like bottom up solution. But I'm not really sure if that would really like save a lot of time. Yeah, I guess I don't know. And then memorization is like another thing that could probably be attempted here, but let me try to think of how to possibly do that.
So since we're a little low on time, I will let you know that it is possible to solve this in O of n time, so in linear.
Okay. Let me think. If I did backtracking, yeah, I don't really know how to do that right off the or I mean dynamic programming like bottom up. I was trying to figure out how to possibly do that, but I'm not really sure right offhand. Yeah, I don't think I know right offhand.
That's okay. We still do have a good amount of time. I encourage you to try if you feel like it's possible. I'll say that there is a dynamic programming solution, but there's a lot of different approaches that don't involve anything like a complicated recurrence relation. You also would be able to just essentially you may be able to do it just by passing around some additional data structures in your recursion rather than just the single index that you have now. I'm also happy to call it early if you'd rather, but I do encourage you to try.
Yeah, okay. Yeah, I guess I'll keep trying. So I mean, potentially, yeah, actually I'm not really sure right offhand. Sorry.
No worries, that's okay.
Yeah.
Yeah, I'm happy to just call it, do some
Yeah,
feedback, answer any questions you have. So I guess right off the bat, I'll mostly just leave it for you as an exercise if you want to continue with the question. I will provide the links to the relevant leak code question if you wanted to try it on there, maybe give another stab at it with the more optimal solution. But I do think that your current one would be optimizable one way or another. So if you wanted to start working on that, feel free to go for it.
yeah, definitely.
But in terms of feedback, I think you did pretty well. I probably wouldn't give this a pass just because we kind of only got to the brute force solution. But I think in terms of, in terms of technical approaches, I think it all made sense. I think that your implementation of, the basic data structure of having, here's the helper function, here's the main function that'll do the initial calls, and then the actual recursive structure was all there and made sense. So I didn't get the sense that you didn't know how to structure recursion functions. So that's awesome. In terms of the actual implementation, I think the debugging went relatively smoothly. It did take a little bit longer than I would have liked, but
Yeah.
honestly wasn't too outside of the ordinary. So I think, had we started with a more optimized solution, I don't think the amount of time you would have spent would have been concerning. And beyond that, I think that the use of logs is really helpful. I think one thing that I would point to that you could improve is just, if you're in an interview where, like most of them, I would say you're able to sort of add these logs and get more information. The placement is really important. I kind of alluded to that once, but currently what you're doing is you're logging before the return statements in every case. So, for example, the log on line 41, you probably would have been able to get to the bugs a little bit faster had you first sort of assigned the result and then logged afterwards. So if you had put something like, here, I'll actually just type this out. So if you had something like result equals, I forget the null, there we go. And then you have, helper result. I guess you could just do it this way. So result equals helper I plus j. And then you say console.log result at bottom result. And then you return result. Then that resolves the problem that seemed like you were facing for a bit, where you get, this I0 jumps I2, J1, all of those outputs. You only get them from the top of the recursion down, but you don't get them going back up, which is where the error was possibly happening. So if you kind of just assign the result and then you log afterwards, then you can see every call that's being made. So that's just one thing that's usually helpful during recursion problems. Yeah, I think that was sort of the main point on the technical end. On the behavioral end, I think a lot of your explanations made sense, but it did feel like it felt like for the first, I would say, 5 to 10 minutes of the interview, you were doing a really good job of communicating and a really good job of kind of, not sort of talking more directly to me as the interviewer about your approach. But then after those 10 minutes, it felt like you sort of pushed down into talking to yourself more than anyone else. So it felt like at some point, you were less doing the really constructive sort of conversation of, okay, well, I'm having this problem. So now what I'm going to do is add a log here. Oh, I printed this out. So now I see this input. Based on that, I now know this. That's kind of how you started it, and then it sort of evolved into I don't really know what this is. I guess I'll just, which is totally normal. It's not.
I'm not really
just
sure what to do, and I get stuck. I give up.
No, that's totally understandable, and it's very normal. One of the things that's sort of separates I would say the 3 out of 4 behavioral score to the 4 out of 4 behavioral score is being able to stay in that mode of I am presenting a solution. And I've also noticed that candidates who are able to do that are also really successful in getting themselves unstuck. It's kind of the effect of, at least I've experienced this a lot, where you are having a coding problem, you are stuck on it for a whole day, or at least many hours. And then you sort of show it to someone else, start explaining it, and then immediately realize, oh, never mind, I fixed my own problem. And then you don't need their help. It's the same thing. It's the same effect where by breaking it down into pieces to explain to someone else what's going on, you kind of break the cycle in your own head, and then you find a solution. So definitely on the behavioral end, I'd recommend trying to, as much as possible, stay in the zone of being a presenter more than someone solving a puzzle.
Okay. Yeah, I don't really know how to practice that. It's like really weird.
I mean, it is very unnatural. You just have to, you can practice it on your own. You do just have to sit in a room by yourself, solve a leak code question, and pretend that there's someone else there.
Just talk through it.
Yeah, just talk through it.
Okay.
Yeah, it is a very awkward thing to learn, but once you get it down, it's super useful. It also is just a thing where the more clear you are in your explanations, the better chance an interviewer has at helping you. Because generally interviewers are instructed to give hints. This isn't like the interviewer is having pity on you. It's like part of the job is to guide you along as part of a collaborative process. But a lot of candidates end up not getting any, the candidates who are good at explaining things get essentially free hints over the ones who don't explain as much, just because it makes it really easy for the interviewer to step in.
Right.
As opposed to candidates who are kind of, you can imagine someone just sitting, not that you were doing this, but someone who's just not talking at all and just staring at the screen. It's impossible for me to give them any guidance.
Right.
I could try to just give away part of the solution, but there's no easy place for me to step in and say, oh, you're thinking about this wrong, or you need to reconsider what you're thinking about this.
Yeah.
Yeah.
Okay, that makes sense. All right, thanks. Yeah, I really appreciate the feedback. It's really helpful.
Yeah, absolutely. And I'll be able to pass back an actual feedback document to you after this as well, which will have mostly the same things, maybe some different things, but also will have some numbers and some other, some other points I think. So that'll be out in the next day or so.
Okay, cool. And then, yeah, I'll make sure to look up the leak code thing and find the most optimal solution, and make sure I understand that.
Yeah, absolutely. For this question, there's a ton of different approaches, which is part of the reason why I ask it, just because there's a lot of flexibility. But yeah, I encourage you to.
Okay, thanks a lot.
Yeah, thank you so much.
Right.
If you have no other questions, I'm happy to drop off. So
okay,
thanks so much.
Cool. Yeah, have a good one.
Have a good rest of your day.
Right. Thanks, you too.